So make sure you're checking your work using the answer key as you go. Don't get all the way to the end of the worksheet and then realize maybe you're making some mistake. Check each problem as you go using the answer key, which is right over to the right of the worksheet as you go. But I did want to talk about a few of the common mistakes and talk about a few good strategies as you're working with these. So one of them is, remember, there's a couple different ways you can do these. You can write a proportion and cross multiply and divide, or you can like use two corresponding parts to identify the scale factor and use that scale factor to find a missing part. So on this problem, first of all, always good to mark these up. You're trying to find the length of WZ. So WZ, WZ. So that's the one that you're trying to find. So it's always good to identify a corresponding part in the shape that has the measurements given. So WZ and EH, those are corresponding sides. They're the short side of the parallelogram. And notice the problem says that these are similar. In all of these problems, it says that the shapes are similar, even if that little symbol isn't drawn between them, indicating that they're similar. And so in order to find the missing side for this one, you would want to identify a pair of sides where you have a pair of corresponding sides where both of them are labeled with their measurements. That would be WX and EF in order to set up your proportion. So with this one, a couple ways you could do it. You might notice that on the longer shape, that side is 3 times longer than its corresponding side on the smaller shape. So the scale factor must be 3, which means you could multiply 3 by 3 in order to get WZ, or you could set up a proportion. And like I said, I encourage you to try using both strategies to solve some of these, just so you're good at using both of them, because some problems are easier to solve using one strategy versus another. So you could also set up a proportion where 6 over 2, that's the ratio of the corresponding short sides, is equal to WZ over 3. And then you could cross multiply and divide, and you should get the same answer. So as you're going down, just make sure you're comparing corresponding parts. And a lot of times when I do these, I think of the proportion itself as having a certain amount of symmetry. So just using another example, you have a small height and a large height, and this is the one that we don't know. And you have the small thing shadow and the large thing shadow, the lengths of those shadows. So when you're setting up a proportion, I always think you're doing, you want to set them up so that they are sort of symmetrical. So I'm going to do the large thing over the small corresponding thing is equal to the large part over the small corresponding part. So it's large over small, height over height, length over length. So there's sort of a symmetry to it, a pattern to setting up your proportion. Because if you scramble up those pieces, even if you cross multiply and divide correctly, if you set up the proportion incorrectly, you end up with the incorrect answer. So if you're getting an incorrect answer, double check that the way you've set up the proportion is sort of symmetrical on either side. The big thing over the small thing on both sides. And you're comparing corresponding parts. So this gets really important when you have shapes that have been maybe flipped around. So these two triangles in number 4 aren't drawn the same way, so that they're both sitting on their short leg like the one on the left is. So sometimes it's good to highlight it or even redraw your shapes so that they're sort of in the same position. I'm just going to use a highlighter. So I'm going to highlight that that corresponds to that. Hypotenuse corresponds to the hypotenuse, and the long leg corresponds to the long leg. So if you're setting up your proportions, make sure, for example, that you're setting it up so that you've got a big side over its corresponding long side. When you're writing this, so you could do something like 24 over 8. That's the ratio of the hypotenuses. And since you're trying to find YX, that's the pink side on the small triangle, you would want to do 18 over the unknown Y yx on the other side. And then cross multiply and divide in order to find yx. Again, on this one, it will help to do some of that highlighting. So highlighting that you've got that and that are corresponding parts. Those two are corresponding parts. And those two are corresponding parts. And if you actually do the highlighting, in some of these problems, some of the proportions down below, you're trying to decide which one correctly describes the relationship between the corresponding sides. So you're looking for which one of these would be a correct proportion to describe the relationships. You can do that same highlighting in order to find that highlight. So for example, like PQ is green, DE is green, 4 goes with PQ, 6 goes with DE, so that would be the correct one. If you were to do the same thing with this, you'll notice you have PQ over DE. That is a small side over the long side, the green one. But then it has 6 over 4 instead of 4 over 6. So this one has flipped over the second ratio. If you're going to have a short side over the long side, the other side of your proportion should also have a short side over the long side, so that one is not correct. The other one, comparing PQ and EF, equals 4 over 9. Notice you've got, well, one thing I don't like about this one is it has different colors. PQ is green, highlighted EF is blue, so that's not comparing corresponding parts. It does have the right numbers, but you're not looking at corresponding parts, so that's not going to work to solve. If you were to put in those unknown pieces and use this to solve a missing part, this wouldn't work very well. And also notice 9 doesn't go with EF, it goes with DF, so that one doesn't work. And you'll notice there's the same problem with the third proportion. On number 6, the big hint I want to give is draw the two shapes. So actually draw the two triangles. This is one of those problems where you have two objects casting shadows, and the object, its height, its shadow length, those form similar triangles, which you can use to set up a proportion and solve for the missing side. And so make sure you're drawing those. So a 6-foot tall person standing next to a flagpole. Let's say this is the person and this is the flagpole. The person is casting a shadow. The flagpole is casting a shadow. If you label those dimensions, remember that those are similar triangles that are formed. That'll help you set up the correct proportion to find the missing piece. For number 7, a couple ways you could do this. First of all, we know that you could set up proportions to find the two missing sides. Either set up proportions or you could identify what the scale factor is. You're given two known sides and you could use those to either set up a proportion, or you could use 5 and 30 in order to find what the scale factor is and then find those other two missing sides on the big triangle. Perimeter is the sum of those sides. But remember, we also found in the previous exercise that if you know what the scale factor is, the side lengths are multiplied by those scale factors. And remember, perimeter is the sum of the side lengths. You could also multiply the perimeter of the small triangle by the scale factor, and it would give you the correct perimeter for the larger triangle without actually finding the missing side. You could do that either way. On this one, just be careful about your units. Notice you're given feet and you're given inches, two different units, and then the shadow length for this tree is given in feet. When you're setting up these proportions, it's always a good idea in any math problem actually, make sure that any numbers that you're using are in the same units. So either change everything to inches or change everything to feet. You'll notice your possible answers though are in feet. So it's a good idea to change all of these to feet. So you could turn 8 inches into 2/3 of a foot. So Remember, 8 inches out of 12 inches simplifies to 2 over 3. And so you could use something like 0.67 or 2 over 3 instead of 8. Use 8 inches as 8 feet, you're going to get a really weird answer that won't make sense. It's also a great idea to, once you've got your answer, to see if it makes sense, is label the diagram with the answer that you got and see if it makes sense. So if you got an answer and you put it in there, and the height of that tree and the length of the shadow that it's casting kind of look weird, they don't look proportional to that 1 foot object and the shadow that it's casting. Notice that a 1 foot object casting an 8-inch shadow, its shadow is a little bit shorter than the height of the object. The same should be true relating the height of the tree and its shadow. Moving down to number 9, if you're having trouble with this one, there's a really common mistake made with this one, and it's because one triangle, the small triangle, is sort of embedded within the large triangle, and it kind of makes it hard to see that there are 2 separate triangles here. What you might actually consider doing with this one is drawing the 2 separate triangles. So draw the small triangle, label it with its pieces, and then draw the larger triangle and label its dimensions. Those are 2 similar triangles. And so if you label those, this would be 2, this would be 3, that would be x. We know that this is 12 and this is 6. And so if you're trying to find that unknown, you can use the 3 and the 6 and the x and the 12 for your 2 ratios in your proportion to solve. On this problem, the most common mistake that I see is people treat the 6 and the 11 as corresponding sides, and then the 5 and the x as corresponding sides. But if you look carefully, that's not the case. So the 5 actually corresponds to 11, and 6 corresponds to x. So when you're setting up your proportion, you could do something like 11 over 5 equals x over 6. But you don't want to try doing something like 6 over 11 equals 5 over x. That's writing ratios of non-corresponding pieces. This one, I would highly encourage you to draw the 2 rectangles for number 11. Or you might remember the relationship between the scale factor and how that scale factor affects the areas of 2 polygons from the previous exercise. So you have a scale factor of 3. That's your scale factor. Remember, that doesn't mean the area is going to be 3 times bigger. Area was affected differently by a scale factor than the coordinates or the side lengths or the perimeters of those 2 shapes. So be careful about that. And if in doubt, just draw the 2 rectangles and calculate their areas. So you're going to have a 5 by 7, and it's going to be enlarged to a 15 by 21. So you could draw a rectangle, or without drawing it, you could also calculate what the area of that rectangle would be.